This is a Colpitts oscillator. So an oscillator is an electronic circuit which does not need any external input. The feedback itself will act as a input. So here the feedback circuit consists of two capacitor and one inductor. This feedback produces 180-degree phase shift, which is given as feedback to the transistor which produces 180-degree phase shift. So totally we have 360-degree phase shift to satisfy the condition of oscillation. This circuit is still more stable when compared to Hartley oscillator. So here we use a transistor BC107. From the emitter we use 1 kilo ohm in parallel with the capacitor 0.1 microfarad. So in the feedback we use two capacitors with one inductor, one capacitor with 0.1 microfarad and 0.01 microfarad with inductor of 10 millihenry. We use coupling capacitors to couple the signals from the output to the input of the feedback and from output of the feedback to the transistor input. From the collector of the transistor we give 2 kilo ohm to the supply and we use R1 R2 voltage divider by circuits in the base. So here we do not give any external input. So we give the same connections in the breadboard. So this is the connection given in the breadboard. We use a transistor with emitter, base and collector. So from the emitter we give a resistor in parallel with a capacitor. Collector we give a resistor to the supply. Supply positive is given here. We are going to give a supply of 12 volt. Negative of the supply is grounded. We use two capacitor with one inductor in the feedback, two inductor with one capacitor. Here we use two capacitors, 0.1 microfarad and 0.01 microfarad with one inductor. Here we are using decayed inductance boxes. So we are going to give 10 millihenry into 1. All the other knobs are kept in 0. So after giving the connection, give the connection to the CRO. So CRO positive has been given. From the collector we use a capacitor, coupling capacitor. From the output of the coupling capacitor we give the positive of CRO. The negative of the CRO is grounded. The CRO will be able to view the sine wave. Here from this we will be able to take or calculate the frequency of oscillation. Thank you.